good. I think I'm on a personal note, we're delighted to have you all today and capturing something that we have missed in the last 3 years since we've been here in this room, in person, proceeding with seminars in construction, in the construction automation lab. This is an excellent opportunity here at the end of this academic year to have that session. And thanks to Hassan and his colleagues, who particularly Hassan was a leader here in organizing the seminar series, particularly during the pandemic, be it in person or hybrid, both ways. So thank you very much, Hassan, for all the good work. Thank you all professors for being here. And then let us proceed with the
I think we can start the Dr. Farzani. You can, if you can.
Yeah, sure.
Okay, you do it, clap.
Good afternoon, everybody. And really, after 2 years isolation, I'm really cheerful to meet you all, specifically Dr. Moussaoui in person. And today I'm here on behalf of Pomerleau, which is one of the biggest general contractor throughout Canada. And I'm here to present innovation at Pomerleau, and I'm going to talk a little bit about myself for those who don't know me. Actually, my name is Farzana Golfu. I earned a bachelor's degree in architecture and master's degree in construction management when I was in my home country, Iran. And after getting some years of experience in, work experience in the construction industry, I preferred to apply abroad to continue my education. So I received my PhD degree in building engineering under the supervision of Dr. Moussaoui from Concordia University. And now I'm an R&D specialist at Pomerleau. Actually, I had the chance to join Pomerleau as an intern when I was close to my thesis statement. And during my PhD and internship, I developed a material management framework utilizing near real-time monitoring of construction operations. And as my research interest, I have worked on application of artificial intelligence, image processing, computer vision, deep learning, natural language processing, Internet of Things in the construction industry. It doesn't mean that I'm expert in all of them. No, just I try to apply different techniques, as I mentioned, in construction industry to solve some problems. Actually, I'm honored for my contributions to liaising between construction projects and research areas to develop and propose some practical initiatives. Actually, in Pomerleau, now we are working on different research projects and also developing POCs, proof of concept. And actually, Pomerleau most of the time collaborates with the universities and hard-working interns to be a pioneer pioneer of the state-of-the-art technology. So it's a good opportunity for the students who want to have internship and doing working on research projects. Today, I want to present two of the developed projects that we did at Pomerleau. This is our team. Actually, we are a big team at innovation department, but the one that I actually contributed to these two projects were Caroline, Jean-François, Said, Sina, Assad, and I. And the first actual project that I want to present you is called is coming from my capture. It was a winner at Cambium Research Award in 2021. It's related to data collection at the job site. I played a video and then has a narrative, and you can see what is this project about.
Pomelo has developed an innovative solution using AI algorithms to create a Boston Dynamics spot robot, enabling environmental intelligence to collect data from various data. Whenever there's progress on the site, those specific locations are marked with QR codes. AI helps spot detect these QR codes to promise data collection. Each round of data collection includes various types of data, such as images, RGB images, point clouds, and QR code information.
Because the voice is not that much. Actually, it's like using a dog spot, and we try to integrate artificial intelligence to the spot because every time that there is a QR code at the job site, the spot can detect the QR code, and based on the progress of the job site, the superintendent or project manager attach a QR code on a specific element. Whenever spot detects the QR code, and it starts to collect data. It can be 360 images, point cloud, or whatever. That's, as you see there are different payloads, laser scanners, and 360 camera on the spot. And the second project that we developed at Pomelo is related to the document analysis. I don't want to go through the details, but as you know, the documents can be categorized in two different classes: searchable, non-searchable. If it's a scanned image, or even if it's a digital created. Just I want to focus on the geotechnical reports, which can be categorized as a searchable document. As you see, we have different providers, and each provider has its own report with different layouts and patterns. And we have to extract specific data from each of these reports and created or generated the output as this table you can see in the bottom. But another problem is that even if a report from one provider has different layouts and patterns in when for example, in page 10 and page 11, even the pattern and layout can be different. So we developed a web app at Pomelo, and this is again a video. I will play it, and then I can. No, it doesn't have a narrative. Just I explain myself. It's an example report for displays. We call it displays, means that the pattern is different in different pages. So the user should annotate just the first page. It means that drawing rectangular around a specific data that he or she wants to extract. And then after annotating the first page, he goes to the web app and upload the document. And as soon as the document is uploaded, the table, the output that I showed you, is automatically generated and extract all these specific data throughout all the PDF file. And as you see here, we have to upload, we have to save and then upload. As you see here, displays means the reports that the patterns in different pages changes actually. And then after uploading, you see the result will be generated, and you can download it. And the pages that there is nothing in front of it, it means that in those pages there is no specific data like in terms of X, Y, and Z in this example. And the other one is called Unified. Again, this is a report that the pattern and layout doesn't change during one PDF. And then again, by annotating the first page and uploading, you can create and actually extracted all the required data. It's not limited to this example, but this is just an example of the POCs that we worked here, we developed at Pomelo. Thank you for listening and your patience. It was my pleasure.
I think the second presenter is Dr. Mo from Hatch. So, Dr. Mohammed Jawad, you can proceed, but let me, if you need to share your file, I think I need to give you the access.
Yeah, I need access to be able to share.
while Hassan is setting this up and giving him access for all the new students, this is not the normal way that we deal with the construction seminars. We only have the speaker, the students, or someone from industry only, being the end of year seminar. And this was Hassan arrangements. And I think he was managed to invite and get accepted invitations from Farzana and from Mu to help share with us their knowledge in that field. And then after that, we'll proceed with the regular presentation from is it the master thesis students? Of Dr. Rebecca's students. Yeah, now we're ready.
Perfect. Can you kindly confirm if my screen is visible?
Yes. Okay. Now perfect.
Now it's good, Mo. It's
Go ahead.
Okay. Yeah. Thank you. So yeah, within the next few minutes, I will cover 4 different areas. Quick background about myself, and also then I will proceed with walking you through a different component of my PhD study. Also briefly, I will explain my recent industry experience, and also that the main purpose of today's presentation is the potential career paths in risk management profession. And we will spend a little more time on the last part of the presentation. So I thought perhaps I can start with something you don't know about me. I spent the first 3 decades of my life in Iran. I grew up in a small village in southeast of Iran. I moved to Canada in 2017 to pursue my PhD under supervision of Professor Osama Moselhi. During my PhD, I did internship with Palmer, which was basically providing a risk maturity evaluation model for construction organization to basically figure out their strengths and weaknesses in risk management procedures. After graduation in 2020, I moved to I started working at Metrolinx, a crown agency of the government of Ontario, as risk analyst. And currently I'm working with Hatch as risk manager. I have few slides, next slide, that we will deep dive more in each of these components. So PhD at Concordia University, as you can see, our goal was to provide an integrated risk management framework for construction and infrastructure project during different phases of project development, in construction phase and pre-construction or bidding phase. So basically, as I explained, we develop a risk maturity evaluation model to benchmark the strengths of a construction organization and compare it with the industry best practices. A contingency estimation model also, because of the uncertainty exists in construction projects, they are very complex. There are a lot of uncertainty. It's very important to establish and develop a realistic budget for construction project, especially in mega and giga project. We kind of try to develop a model that will eventually improve the accuracy of the contingency budget. Also, markup estimation using different algorithms. We're able to develop a model for markup estimation, another model for cost-time trade-off analysis that can be used during construction and pre-construction phases as well, and also a model for forecasting and evaluating schedule performance index and forecasting the potential delay. So this is basically a very brief summary of what I did at Concordia University. And as I said, the goal was to provide more realistic and reliable schedule and cost estimation for construction and infrastructure project to increase the chance of successful delivery of this class of project. So I will move to the next slide, which kind of highlights what I did during my employment at Metrolinx. There is a huge mandate under Metrolinx, supervision taking place in Greater Toronto area. 75 billion projects investment in transit and transportation project is taking place currently in Ontario province. So I became a part of the project delivery group. Under project delivery group, we had different program. I worked in light rail transit program. At that time, there was 3 different mega projects here in Ontario. Light rail transit program, 18 kilometers light rail transit. This was basically the area of focus. I was basically responsible for providing risk management services for here Ontario project with a budget of $4.6 billion. The project is being constructed under design, build, finance, operation and maintenance project delivery system. Also, another two project, Eglinton Crosstown LRT, it is at final stage with the budget of $9.1 billion. $2.5 billion scope for Finch West LRT, and also recently a new project included in this portfolio, which is Hamilton LRT project. So I was in charge of providing quantitative and qualitative schedule and cost risk analysis, having involvement with different stakeholders, internal and external stakeholders. Doing gap analysis and incorporating lesson learned from a similar project using pattern recognition techniques to identify the area of focus, and basically also implementing lesson learned to be proactive and identify basically the potential exposure and plan mitigation actions for basically being ahead of those occurrences and minimize their exposure. So this is a summary of basically my experience at Metrolinx. I joined Metrolinx 2021, right after I graduated from Concordia University. And recently I joined Hatch. As I said, like at Metrolinx, the main focus of my work was on infrastructure projects during construction phase. However, at Hatch, I provide risk management services to different sectors, including infrastructure, mining, and energy internationally. So we have different offices in different, countries. So I have involvement currently in one of the biggest and largest infrastructure project in the history of Ontario province, a giga project, in infrastructure project, also some involvement in mining and energy sector. So I would like to stop here for the and spend more time on the career path in risk management profession, because that's very important currently because of all the uncertainty that's happening, COVID-19 impact, supply chain problem, strikes, lots of uncertainty are going on, and many companies, even either from government side or a private company, are willing to invest more on risk management, like their capabilities in risk management. There are a lot of demand, and we currently have shortage of risk resources and practitioners in the market. So I think one of the best place that we can create this momentum is by engaging at students and professionals at the early stage of their careers at university. That's why I prepared one slide which kind of in a very brief summary highlight different paths that you can engage and involved in risk management professions. You need the knowledge area of scheduling, cost estimating, cost engineering. And this is basically the first path that you can enter through each of this area and basically be a certified risk management. Or within the last few years, also a new path has been created. This is the path that I have taken, being a risk analyst, continue with risk lead, risk manager, and then you will have the chance and opportunity to get some position in higher authority. Also, very brief summary of the survey that has been conducted by AACE in 2018. As you can see, this is the average salary as per each area of study and each discipline. By being interested in risk management field, you will have also a good chance of making good salary and income. So we have lots of internship position at Hatch. We are interested to engage with students at late stage of their study. In case you are interested to basically pursue your career path under risk management, please feel free to reach out to me. You have my email here. I would be happy to provide you with more insight. Thank you.
Thank you so much, Mark, for your great presentation. You don't mind if you can share your screen?
Sorry?
If you stop sharing, please.
Yeah, I will stop sharing, and please accept my apologies. I have a meeting with our clients, which was scheduled early. I have to leave at 1:30. So, but it was great to be here.
Thank you so much for joining, Mo. I appreciate it. Okay, have a good day.
Pleasure.
Are you going to be leaving, or you will continue with the seminar?
No, I think Mo has a meeting.
Okay, you have a meeting. Okay. Thank you very much, Mo, for being here with us. Thanks.
Thank you very much.
Thank
Have a
you.
good day.
It's nice
Bye.
to see you. This
Yeah.
is Ashutosh Bagchi.
Oh,
Nice to see
Thank you.
you.
Thank you very much, Dr.
You can
Bakshi.
see me.
Glad to see all of
I'm
you.
off the camera.
No, they
Thank
can
you very
see
much.
that.
Have a
okay,
great rest of the day. Bye.
Right.
Okay,
Okay,
I see the real thing, the real presentation from a real student, and the discussion after that. So, Alex, the floor is yours.
Thank you for the introduction, Mr. Maselli, Professor Maselli. My name is Alex Griswold. Thank you for having me here today in the Construction Automation Lab and giving me the opportunity to present some of my research in the seminar. Once we get the screen working, I'll be able to introduce the topic a little bit more. But I am a Master's of Applied Science candidate here at Concordia University. I am supervised by Rebecca Zeitzich. And I will be presenting some of our research in predicting pump as turbine characteristics with the use of machine learning. So in today's presentation, I'll be going over what exactly is a pump as turbine. I'll also be going over some literature and some machine learning applications that have already been done. I will make the statement of the study and what impacts will come from the study. Then I'll go into the data sets and the information within those data sets and how they'll be used and how they'll be manipulated within the machine learning method. Then I'll go into a step-by-step analysis of the methodology, followed by the results, and then I'll give some concluding remarks from these results and from everything that comes from the machine learning process. So first of all, what is a PAT or a pump as turbine? So it is a conventional hydro pump set in a reverse orientation coupled with a generator to act as a turbine. So these are cost effective with a quick payback period compared to other micro hydro turbines. They are also mass produced and require minimal to no maintenance once they are actually installed. The downsides to them, however, are that the characteristic curves in turbine mode are not provided by the manufacturer. And they are also limited in operating ranges, typically less than 100 meters in head and less than 200 liters per second in flow. So to get a little bit better of an idea as to the applicable range of PATs within water distribution networks, we see here in this graph that we have a grayed out region of the actual ranges we want for heads and flow values in a water distribution network. And we can see that we have traditional Pelton, Francis, and Kaplan turbines graphed on this representation. But we also have different typologies in pumps as turbines, the multi-stage PAT, double suction, and axial. But we can see that the classic PAT or centrifugal PAT fits well within these bounds. So that's another thing to keep in mind as we're going through within the study. So the important operating details that we need to consider when we are looking at PATs are the best efficiency points of the PAT in pump mode, the characteristic and efficiency curves of the PAT. And we do know that the manufacturer provide these curves whenever they do sell the product. So with this, there has been some authors who created equations to predict how the turbine will act based on its pump mode characteristics. So for instance, Alatori Frank created an equation based on the efficiency of the pump as well as the best efficiency flow in the pump to gain its turbine, to predict its turbine flow, as well as for the head. And for example, Rossi's equation will create these characteristic curves based on these values extracted from the best efficiency points. So they do vary in accuracy depending on the applicable ranges of flow rates for each equation. And they have also been developed with limited samples, usually within the 4 to 36 PAT range. So basically we need the turbine best efficiency point values prior to creating the characteristic curves. Now to get a little bit better of an idea of this process, let's have an example of a pump that's been extracted from a catalog and its corresponding characteristic curves. We can see that we have the efficiency curve in green, head curve in blue, and the power curve in orange. So from here, we can find that we have a best efficiency point and we extract these values. From here, using Alice Frank's equation, we can then predict at what point the best efficiency point will be in turbine mode. So we determine what that point is. And then finally, using Rossi's equation, we can create these predicted characteristic curves to gain knowledge as to if the PAT can fit within certain situations within the water distribution network. Another thing that we have to take into account when we are looking at pumps within a pressurized water distribution network are the dimensionless parameters. So the flow, head, and power attributes in a dimension perspective have dimensionless attributes, which can be represented as phi, psi, and lambda respectively. So we need to just keep this in mind as we're going through the process in terms of the whole analysis for applying machine learning in this regard. So now on to machine learning. An example of an application that has been done in this similar regard is a study done by Rossi and Renzi, in which they use neural networks on a library of 36 PATs to predict the behavior of the PAT in turbine mode based on its pump mode parameters. So we also need to keep in mind that the input variables should be independent of each other, as well as the geometry of the PAT. As I mentioned before, we have several different typologies, all within different operating ranges. So there are linear regression models that are offered by scikit-learn and XGBoost, which we will be looking at within the current study. And the typical train test split of the data was used within an 80-20 perspective, but depending on the results and the quality of fits, they were either changed from 70-30 or 90-10, and to see if better results or better fits were achieved with this adjusted range of the train test split. So here is some examples of the regression libraries that I use within the scikit-learn library, and the one regression model that I use from XGBoost. So one thing noticed within literature is that, as I mentioned before, the dimensionless parameters do need to take into consideration all of the pump parameter specifications, namely the rotational speed and the diameter of the pump. So by definition, by looking at the equations, we can see that they are included within the equations. And in the literature, whenever there was an application of machine learning within a certain perspective, they took the rotational speed into consideration. But as I previously mentioned, this information is already within the dimensionless parameters. So within this study, to make sure all the input variables are independent of each other, whenever we're looking at the data in the dimensionless perspective, we will not be considering the rotational speed of the impeller diameter when we're putting the variables into the machine learning algorithm. So for the goal of the study, we are going to investigate the reliability of machine learning in terms of predicting the best efficiency point and characteristic curves of a PAT with both a dimension and dimensionless library. So looking at our data sets, first we'll look at our best efficiency point data set. This initial data set contained a total of 215 samples, all of which were extracted from articles with experimental results of PATs from pump mode and turbine mode. The dimensionless library was then created with the equations previously shown, and that was used as a separate library to compare the capabilities of the dimensionless library to apply in a machine learning perspective. So the cleansed data set contained 145 data points or across 145 different PATs. Now this is considering only the centrifugal pumps as well as any extreme values in head and flow were then extracted from the actual data set. So as I mentioned before, we do need to take into account the dimensionless variables and their dependability on other attributes. So for our input variables, we can see that for our dimensioned data set, we have the impeller diameter, the best efficiency point for the flow, head, and efficiency, as well as the specific speed and the rotational speed. For our output variables, we are going to be determining the best efficiency point for the flow, head, and efficiency. When we look at it in a dimensionless perspective, we're pretty much looking at the same variables and the same output variables, except we are taking out the rotational speed and impeller diameter to make sure that there's no dependability within the actual parameters. Now onto the characteristic curve data set. So all the data regarding the characteristic curve data set was extracted from the Red Dawn Association. And they had information regarding 38 different pumps in terms of their pump data and their turbine data. So once again, the dimensionless library was created with the equations, the dimensionless equations previously shown. And the final cleansed data set contained 196 data points across 21 pumps. So almost every pump had between 7 and 9 data points for the head, flow, and efficiency ranges. Once again, when we're looking at our input and output variables, we have one more variable for our input variable regarding the characteristic curves, and that would be the turbine flow value, the normalized turbine flow values. So we want to know how the turbine is going to react over different flow rates. And so we already know that information. So that's why that is going to be determined as an input variable. And what we want to gain from this are the turbine head values and the efficiency values to make sure that the PAT can fit within certain situations. Once again, when we look at the dimensionless perspective, we can see that the rotational speed and the impeller diameter were emitted from the input variables to make sure that there's no dependability within the variables. So as we're looking at the main attributes in turbine mode against pump mode, we have our flow, head, and efficiency values. And we can see that there is a linear trend going on between all of them, but they all vary in strength. So we can see that the flow values in turbine mode against pump values show a pretty strong linear correlation, especially within the lower flow rates. Whenever we move on to the head, we see there is still a linear trend going on, but with a little bit more scattering of the values. And for the efficiency, we can see that there's a lot more scattering of the values, but there is somewhat of a linear trend going on. Now looking at the characteristic curves. So as I mentioned before, we want to know what the flow rate is across different head ranges. So that's why we're looking at the normalized flow rate against the normalized head values in turbine mode. So we can see that there is a strong linear correlation going on between all these values, but a stronger linear relationship with near the middle ranges. However, if we look at the normalized efficiency curve values, we can see that there's a little bit more of a parabolic shape going on rather than a linear relationship. So this is to be kept in mind as we look at the results a little bit later on. Now for the methodology. The methodology was basically split up into three main parts. The first part was the initial survey regarding our library of regression models and our data sets. So we picked a predicting attribute, let's say the head, best efficiency point for the head, and we compared it against all the regression models offered or studied within this study. It went through the train test split, and it was evaluated based on its R-squared score. And then based on this R-squared score, the best predicting model was then extracted. From there, the model was then underwent an hyperparameter tuning process. So this was done by looking at the hyperparameters and determining which ones were the best to undergo hyperparameter tuning, which mainly were all of them. And this was done using a random search CV across all the applicable parameters. So within an initial range was given to give an idea as to which ranges of hyperparameters to be tuned in within what range. But whenever the hyperparameters were given, and if they came either at the maximum or minimum range of those hyperparameters, the range was then readjusted, and then the whole process went through the random search CV again to see if the hyperparameters would have more opportunity for a better fit within the model. And lastly, once the model has gone through its hyperparameter process, the model is then evaluated based on its quality of fit to the data. And then if this was done for both the default and optimized model, and then the model was then evaluated based on this root mean squared error and its median absolute deviation of the results. So now onto some of the results. This is pertaining to the best efficiency point predictions for the flow head and efficiency in both the dimension and dimensionless scenario. We can see that the Huber regressors seem to be pretty popular for both the flow and dimension and dimensionless perspective. And also the efficiency seems to be popular for the efficiency in both the dimensionless and dimension. Sorry, the orthogonal matching pursuit was the popular model in the efficiency in a dimension and dimensionless perspective. So we can also see that sometimes our values reduced in R-squared methods after it went through the hyperparameter tuning process. And we can see that going from the default R-squared to the optimized R-squared. And once again, we can see that the dimension library seem to be the stronger library to be used to predict the best efficiency points of the PAT. And this is obvious within the optimized R squared scores whenever we look at the head in both the dimension and dimensionless perspective, since that's the attribute that has the most difference in scores. So now whenever we plot the true values against the predicted values, we can sort of see how the model reacted based on the scores. So we can see for the flow values, we have a strong R squared score, and we do have a pretty strong linear relationship going on. Rather than if we look at the head, we can see that there's a little bit less linear correlation going on with the reduced score. And once again, in the efficiency, there's a little bit more scattering of the results, and that is reflected in the lower R squared score. Now onto the characteristic curve results. We can see that for every attribute, the XGB regressor was the favored model. And for both the head curve and the dimension and dimensionless perspective, they came up with almost the exact same score. However, if we look at the efficiency curve, we can see that the default model was stronger in the dimensionless perspective, but it was stronger after it went through hyperparameter tuning in the dimension perspective. Once again, once we look at the true against predicted values, we can see that the head curve shows a very strong linear correlation between its true and predicted values with its very good score of 0.997. And when we look at the efficiency curve values, we can see that there is still a linear trend going on, but with a little bit lower of an R squared score. So comparing this machine learning method was done against a few other equations, as I previously said that there has been research done in creating equations to predict the best efficiency point. So the current study outscored every model in terms of predicting the best efficiency point for the head, but there was one model that did perform just as strongly, which was the Yang model. But if you look at its corresponding head equation results, you can see that the current study showed superior results. And this is also reflected in the errors associated to this model. Now, when we're looking at the characteristic curve results, the current model outperformed every other equations by a decent margin. And once again, this is also reflected within the actual errors and against the other models. So some of the limitations that were applied to this study was that the data points and the input data was only relevant to centrifugal pumps. So as I mentioned before, there was actual multi-stage and double suction PATs, but to take the geometry into consideration is an important part to make sure that the models will stay consistent with each other. We were also limited to using just linear regressions within this current study. But as you saw within the efficiency curve, there was more of a parabolic model, trend going on. Also, the availability of data on PATs is quite sparse. So as I mentioned, the cleansed data set had 145 data points, but in machine learning, ideally you have thousands, if not more, to create a reliable model as well as a stronger model and an applicable model over more ranges. And with that in mind, there is also only limited features associated to PATs, and that can be to the actual geometry of the PAT relating to its diameter, the capabilities it has, and obviously the orientation geometry. If we had more information on different geometries, then that could possibly be another input factor for the machine learning model. But since there's very little information on all those other different typologies, that's why we only focus on centrifugal pumps for this study. So the main benefits that come from this study is the fact that we have a perspective against dimensionless data sets and their capabilities of creating a machine learning model. So as we saw, the dimension data set was the stronger model compared to the dimensionless for the best efficiency point. And they both seem to perform pretty well for the characteristic curve results. And whenever we look at the machine learning model across other equations, we see that the current model outperforms all the other equations. And within the other equations, they have been developed within certain ranges. So depending on the amount of information we have of the PAT across different flow rate values or head values, the range of this model can be more wide. And there's, of course, the opportunity to increase the dependability with the opportunity of getting more data and compressing it or using it within the machine learning perspective. So the next steps relating to predicting PATs using machine learning would be to use an artificial neural network. Once again, using both the dimension and dimensionless data set to see the differences in their capabilities of predicting the characteristics of PATs, and also to commission it in a water distribution network. So there are specific locations within water distribution networks where you can apply a PAT and harness energy from. So using an optimization method might be ideal in terms of determining these locations. So in conclusion, machine learning proves to be a superior method against the established equations in predicting PAT behavior. The dimension library seems to be best for the best efficiency point, and the dimensionless library was the best for the characteristic curve results. And once again, there is opportunity for improvement with the machine learning methods with the availability of more data as it becomes available. So here are my references regarding the presentation today, and I'll be taking questions. Thank you very much.
I wonder, have you attended before any seminars?
I have not.
Okay, so this is not an exam. We're trying, when we ask you questions, just relax. And the idea here is really to help students with feedback from faculty members, from your own colleagues, and also exchanging knowledge with the rest of the students. So absolutely relax. This is highly informal, and we'll start with questions and comments from maybe faculty members in the beginning and then students. Perfect. Any questions?
Maybe I can start off with a question.
We have the chair of the department.
It's very interesting presentation. I didn't know that we can have a pump in a reverse order to use it as a generator, when we're speaking.
Right.
So not generator, I mean turbine.
Mhm.
So I'm just looking at your presentation. I'm thinking of the practical applications. You know, one obvious application that you mentioned, that you can put it in a water distribution network. Whenever you have head available, then you can use it as a turbine. But when you need to pump it out, you can use it as a pump, right?
So, sorry, did you have more to say?
Yeah, no, that could be a reasonably obvious application, if I'm okay, right, about that. What could be other kind of application? First, two questions here.
Yeah.
One is that an obvious application, or is there other applications that you have in your mind?
So to address your first question, the pump as turbine will only be acted as a turbine whenever it's switched from its pump orientation to its turbine orientation.
Right.
So it will not be pumping water out in any regard. It will solely be acting as a turbine within a certain situation.
No, I understand that.
Okay.
But that part is an automation question.
Okay.
Whether when you switch, either you manually switch its mode of operation, or you automatically switch its operation. My question is not about that.
Okay.
My question is its ability of acting as a pump,
Yeah,
or as a turbine, depending on the case, right? So if you use it in a water distribution network,
yeah,
I just want to see when it will work as a pump, when it will work as a turbine.
Okay. So if I'm understanding your question correctly, you're asking if it'll be used within both scenarios at certain locations, because I'm just looking at the turbine capabilities of the pump as turbine.
Yeah, but I'm looking at both, because when you say pump as turbine, that means it is a pump. It can work as a turbine.
Yeah, but whenever it's installed, it'll only be working as a turbine.
Okay, but why do you want to restrict that? If it has the capability.
Because whenever we compare this to other turbines,
Yeah.
other turbines are significantly more expensive. Usually PATs will cost 1/10 of the cost of a traditional turbine. So that's one of the big benefits of using a turbine, PAT, rather than a conventional turbine.
That's reasonable, but I think it still restricts the use. You know, I don't know. I mean, there could be an application
For sure.
where you could use it in both mode depending on the cases.
It could be, but
And the switching over could be automated with some kind of sensing devices.
It could be, but as I mentioned before, once you put it in as a turbine, it needs to be coupled with a generator.
Okay.
So once it's coupled with a generator, it's going to be harnessing energy.
Right.
So the automation process will probably have to be disconnecting the generator and putting it in.
Yeah, sure.
So that might be, a quite expensive automation process.
So typical applications is, these are, I understand that this will be used as a low duty turbine.
Pardon me.
It will be used as a low duty turbine.
Sorry, I'm not catching that.
So the pump.
Yeah.
You're saying it is significantly cheaper than regular turbines.
That's right.
Right?
Yeah.
So that means when it is used as a turbine, it is not used for a heavy duty work. It is used as a low duty work.
Yeah. So traditionally within water distribution networks, the head and flow rates are lower. So
That's right.
that's why it'd be a good fit within those scenarios.
Okay. No, that's understandable. I wanted to clarify that.
Yeah.
Now I'm just thinking of a scenario.
Mhm.
Cities like Montreal, Ottawa, and all these cities, they encourage the homeowners quite a bit to attain sustainability, to harvest rainwater,
Mhm.
right? Even I remember at one point, city of Ottawa was distributing the barrels to freely for homeowners to collect rainwater,
Okay.
coming from the rain pipes. Now, if in a rainy season, there could be significant amount of rain.
Yeah.
And a lot of water can get collected.
Mhm.
And there is also a lot of energy in that water.
Yeah.
So can a low duty pump like this be connected to a generator to harvest energy as well?
So the current study was only pretty much done on supplying water to households.
Correct.
So it could most likely be connected to the wastewater systems,
Mhm.
but you also need to take into account that the wastewater systems probably have lots of residue and lots of
Yeah.
stuff from the streets. And
Yeah, but this is rainwater,
Mhm.
not wastewater. This is stormwater.
Stormwater, okay.
Stormwater means coming from the rain. It's relatively clean.
Okay.
Although it will carry some debris from the roof.
Right.
But you could put a filter or something.
Of course.
That could mitigate that.
Yeah, well, of course.
Think about that.
if
You know,
the- if the
it could
application-
generate a patent for you at some point.
Yeah, for sure.
Okay, thank you.
Thank you very much.
Other comments or questions? From students, yes. I just wanted to give you a hint. In the beginning of any presentation, who will be the end user of your work? For example, you finish your thesis, you've developed something that is interesting, you have already validated your model. Who will be the end user of your work?
So ideally, within this specific scenario, it
Yes.
would be municipalities, right?
Okay, so they would do what? They will have these pumps turned to turbines, and then they would install it in the systems to do what with it. And a little bit of that in the beginning would really describe how important the project is.
Okay.
And who could be the end beneficiary
Right.
of this beautiful transformation or of. But again, if you extend that all the way, the questions of Dr. Bache, why people then should have turbines at all? So the manufacturers of turbine, why should they produce them?
Mhm.
Well, they could use also the pumps and they change the pump into a turbine.
So sorry, I don't think I.
You know, if the idea is the price is 1 to 10.
Yeah.
Why people will produce any turbines anyway?
Well, it's mainly with the capabilities as well, and the fact that the manufacturers are not giving the opportunity to see that the geometry of the pump as turbine can be reversed into a turbine. So that's why they don't provide the turbine curves of the pumps.
I think my question will drive towards the limitations where this is becoming applicable, the scalability, to
Right.
what degree any pump could be changed into a turbine. And I think with the price of 1 to 10,
Mhm.
I think there would be no market at all for turbines. People
sure.
only will produce the pumps, and then they would change them into turbines.
For sure, but
But I would assume that there has to be a limitations. Not any pump can be efficiently changed into a turbine.
Right.
And I think here's the idea is the limitation of the model that you're developing.
Okay.
If that, I myself don't know, I'm not aware of that field. So
Right.
this is why I'm telling you, common sense.
Yeah.
Yeah, otherwise, I mean, no people that are producing these turbines will stop producing them.
well, that's a good consideration.
Yeah, take a look at it, and if there is a limitation, this would be the limitations for that transformation. That could be of good use, but for a limited scope of work.
And in this context, always keep the user in your mind.
Yeah.
What would be the practical application for instance?
I think
Any
Dr.
other
Solomon has his hands up.
Okay. Dr. Solomon,
Hi,
yeah, go ahead, please.
hi, Alex. Thank you for your presentation. It's a very interesting topic. I just would like to ask, about the model. You mentioned that you collect a quite number of data and then you use it to check the model and predict the results, and getting, I think, like 0.89 and 0.9 as a value. And at the end, you end up with the presentation by saying that you are looking for more data. So what do you think, what will be the improvement, or why do you need more data if you are getting 0.8 and 0.9 as a value between the predicted?
So that's a very good question, especially since there is the data is showing high scores, but once again, that is within a small range of data that has been collected. And whenever we did see some of the results shown against each other, namely the linearity between the flow of the turbine, the flow of the PAT in turbine and pump mode, we can see that there's a lot of data within the lower flow rate ranges, but then the data for the higher flow rate ranges is a little bit more sparse. So the model could be a little bit more biased towards those data points, especially if they line up directly on that line. Whereas, let's say if we have higher flow rate ranges, maybe those flow ranges are significantly higher in pump mode rather than flow mode. So then the model would not be able to properly predict those values. But as I said, 145 data points in a data science or machine learning perspective is significantly small. And to sort of reinforce those scores and to reinforce the reliability of the model, checking the reliability between the data set now and having, let's say, 1,000 data points would help to prove the model and to prove its capabilities within certain ranges, I would think.
Okay, thank you.
I have a question related to the regression that you use.
Yeah.
Actually, when we use regression, we are trying to find an equation at the end of the day
Right.
to give some input and have the output.
Yeah.
But you mentioned that there are some equations that somehow you have some inputs and you can see the efficiency at the end. But I couldn't understand those equations and what are the inputs into those equations, and why, when we have the equations, again, we are doing regression to generate another equation to understand the correlation between the. Could you please explain more about that?
Yes, 100%. And that is another good question. And I think you're referring to the established equations
Yes.
from algebraic Franklin.
Exactly.
So those equations, they solely rely on for the best efficiency point equations specifically, they rely on the efficiency of the pump.
Okay.
And this efficiency of the pump, depending on the equation, is assumed. It's not necessarily calculated. It's assumed based on its pump mode attributes.
Okay.
So with that in mind, it's a prediction. It's a prediction based on a theoretical assumption.
Okay.
So with that, the variability in accuracy of the values given can be questionable. And they have, sorry. Yeah.
What are the inputs for those equations? Even I mean, there are a lot of assumptions and not that much accurate. What
For
are
sure.
the inputs?
So it differs from equation to equation, but the majority of those equations, it's only the efficiency of the pump. And for some other models, it's the specific speed in pump mode or the theoretical specific speed in turbine mode. So they all have different inputs. And so they, regarding on the information you have on the pump, you may or may not have that information. Regarding the pump as turbine, with the inputs presented today, this is all information you should know about the pump. And with that, you will be able to get information regarding the turbine mode based on more concrete inputs in the model.
Okay, I got it. Thank you.
Any other comments?
Can I follow up? on
Yeah.
this? So you showed
End of the
whatever
day.
data you have, sorry, yes, just cut you off.
Yeah.
Whatever data you have, it shows a nice linear trend in most of the cases except for efficiency.
That's right.
So if we just do linear regression using any ordinary method like this for fitting or
Yeah.
something like that, that should solve our purpose, right? So what is the role of machine learning here?
For this specific model.
Yeah.
Well, especially whenever we looked at the lower efficiency ranges, we can see that there's a lot of dispersion in those efficiency values. It did not show a strong sort of correlation. So especially with the equations that have been developed, they are saying that the line goes completely through that trend, and it might go especially through the dense areas of the efficiency line. But as I said, in the lower efficiency ranges, the data was more scattered. So then there's more variability and error pertaining to the scattering of those data points.
That's reasonable.
Okay.
Yeah, actually, I'm also confused about this part because it's like you mentioned machine learning, and it
Yeah.
seems like that's the main tool that you use throughout your study. But they also say in the conclusion, you say linear regression. So which one you use on purpose?
So I'm using machine learning to create linear regressions,
Okay.
depending on the inputs, as I previously shown on the
And
previous.
the machine learning you use is
No, in this study, I have not used ANN. It's just
use-
linear regression.
So maybe if I
Yeah.
intervene, like multilinear regression can be considered a machine learning method. But I have to agree with my colleagues that we really have machine learning. I mean, this is
Yeah.
a simple linear regression
Mhm.
or anything beyond. That's, I think, the question.
Well, I think the answer to that, and I'm hoping, is that there's multiple inputs in this scenario rather than a single input.
But
So-
here's the thing. I totally agree with Dr. Nick Fact. So it's like if you ask me a yes or no question, if linear regression, simple linear regression is machine learning, I can say yes. But normally speaking, especially if we are not using general linear regression, GLR,
Yeah.
normally we consider it as a more traditional statistical method. So that's
Okay.
where the confusion come from, you know what
Okay.
I'm saying?
Yeah.
So yeah, so and actually this really matters because if I don't get it wrong, you mentioned you use 150 data points, right?
Yeah, or approximately.
Okay. Roughly speaking, of course it's case by case, but roughly speaking, 150 data points for simple linear regression is not small data set.
Okay.
Okay. But if you that's for let's say no matter ANN or whatever, SVM, whatever, that's very small.
Yeah.
Especially if that database is biased towards a specific area.
Right.
And if you actually use what I said, it's like whatever the relatives, and you have a biased data set with 150 inputs, even though the result is good, there's a high dangerous risk of overfitting.
Okay.
So we are not playing with words. We are it's
Yeah.
like
No, I understand.
that really influence the quality of your final outcomes.
Yeah.
of
This
course.
actually fixes one of your biggest limitations because with 400 data points, there is no way we can train machine to do anything. But it's more than enough for a regression. So I think even though it's always great to rebrand what we're doing under what is the buzzword,
Yeah.
in your case, I think it's harming more than helping.
Okay.
To call it machine learning.
Okay.
Yeah.
You have a very solid model for linear regression.
Okay. Now, in terms of, just so that I can ask a question, if we were to compare the 145 data points, you're saying that for a regression model, it is sufficient depending on the data. Let's say if we were to compare that to an ANN model, which we're
No.
trying to,
Normally, though.
okay.
And given the data that you have, the variability, the level of variation that you have in your data, you really don't even need an ANN.
Okay.
This is a very well, all the correlations are linear.
Okay.
And the linear regression serves the purpose.
Yes.
Why should you fit? And you have 98% R square.
Yeah.
Why should I go
That's
after
very
it? What am I?
high.
What
That's
if it was
functionally
actually
high.
if it was a machine learning model and you get an R score of 0.98, you should have spent like hours to defend your model.
Yeah,
That's
yeah,
not
yeah.
an overfit.
Okay.
That's a dangerous number actually for, for machine learning. model.
Right.
So what you're doing is great, but it's probably branded. It's not. You're not branding it correctly.
Okay.
That's
The point here for you, Alex,
Yeah.
is, and for all the students, when you select a model or a method, you need to have some rationale or justification why this would be the best way of modeling or representing your data.
Mhm.
So this is just a feedback for you, and reflect on it. As I said, this is not the exam. This is only to help all students here. You have learned about what Alex is doing. We've learned about what the professors have said in that area, and just reflect on that.
Yeah.
Other comments or points? We have good 15 minutes to go, or less than that. Yes.
Yeah, and it's like actually we have that questions from our guests. Why the variables that in your regression model important is? Let's come back to the amount of data points. The thing is like the more variables you involve, the more, I mean, generally speaking, the more data points you need. So that's why how the equation looks like really matters.
Okay.
That's another thing. And I have last question for you. I really glad that you mentioned that you care about the independence of the variables. But it's like what efforts you made to verify
Verify the independence.
of the variables.
Well, as I mentioned before, I initially ran the dimensionless scenario, including the rotational speed and the diameter. But within inspection on the dimensionless equations, you can see that the rotational speed and the diameter is included within those equations. So then I just thought that, okay, so there's information of the impeller diameter as an input, but that information is already within the dimensionless parameters. So I just thought that since if that number would change, then those numbers would change as well. So that's why eliminating them from the inputs of the dimensionless data set specifically would decrease the risk of having dependability between the attributes.
I want to go back to the practical applications again.
Okay.
Just relax a little bit. Have you visited any of the municipalities and learned from maybe either the facility manager over there, taking care particularly, you'll find them in big cities, they are fragmented. So the water distribution, they don't speak to sewers, and both do not speak to roads. And it seems to me that they function independently somehow. Did you speak for those who are managing water distribution network? What is the purpose? Because if you're saying that the end user is a facility manager over there in a municipality, I wanted to know from you, I wanted to understand from you, in what way that could be of help to him or her.
Okay, and that is a good question. Especially we did have the opportunity in talking to the facilities manager in Halifax, where they did have a implication of a micro hydro turbine specifically, not a PAT, but a micro hydro turbine. So it's the more expensive version of the PAT.
But why they wanted it for to do what exactly?
It was to harness the energy, because within water distribution networks, there is locations where the pressure needs to be reduced significantly.
You're correct.
And these can be replaced by a PRP.
Okay.
And so they went ahead and did that.
Very good. Also, the add-on generator, for example, once you have that turbine, you wanted the generator, and you want to link that. How collectively, how this would be sporadic over the distribution network, or at the end, how this will be collected and we will have an energy source. How would that, I'm looking now at the entire distribution network.
Right.
Water distribution networks in a city like Montreal,
For
or even a district, if they have even zoned it into different zones.
Right.
How could that be done?
So as you mentioned, yes, it'll have to be at the locations within where we would have the opportunities.
Okay.
And from there, you could connect it to a smart grid or back to the grid to power the facility, something within the facilities themselves. Or if the power yield is high enough, sell back to
The people in Halifax, once they do that, as you said, they already bought the expensive system.
Yeah.
What do they do with it? They generate it. Now they solve the problem of reduction of pressure as needed.
Mhm.
In addition to that, they already harness some good energy.
Yeah.
How do they make good use of that at the end?
So if I'm not mistaken, I think the facilities manager said that it helps power their facilities and within their housing units of their pumps as well as their water distribution
This is the
systems.
food for thoughts. Think about it. Now I've harnessed energy,
Where does it
the
go?
distributed energy
Yeah.
across the water distribution network. How I'm going to make good use of that?
Of course.
Yeah. Okay.
I
Any
have
other
a
comments?
follow-up question from this.
Hmm.
This is an interesting question.
Mhm.
You know, I don't have much knowledge in this area. I'm completely in a different area. But if I just fall back on my undergraduate knowledge,
Yes.
when you design a water distribution network,
Mhm.
you know, we always calculate loss and all these things, how
Right.
much air is available, those kind of things.
Mhm.
Now, if you put a turbine here,
Yeah.
and water is going through it to generate energy, which is introducing a lot of loss,
Mhm.
right?
Yeah.
So we need to make sure that the end point we have enough pressure.
Yeah.
Otherwise, we have to pump it again in order to make sure we distribute.
Of course.
Now, to make the water distribution network work,
Mhm.
we are already pumping at the source, right?
Not necessarily. It
Or
could be
we
gravity
have a
fed.
head,
Yeah.
yeah. Now, if we lose it, you know, and wanted to recover it, then we are working at a cross purpose. So I think it will be part of the design of the system,
Mhm.
right? And well thought out design beforehand, before we even introduce this kind of things on an ad hoc basis. We should not do it. Right?
Exactly, yes. So as you mentioned, lots of things need to be considered. The demand getting to where it's at, the necessary pressures getting to where it's needed. And so yes, within designing or optimizing the locations, these things definitely need to be taken into
So that will be another problem, I guess.
Yep.
But I think also not to withstanding all of what we said on your work, that would be really a pioneering work and could be very innovative. And I really need to encourage you and also your supervisor to push this further on how, but by looking at all the aspects that would impact this process, because if we could be witnessing, frankly, something that is really innovative and would have a major impact, not simple.
Right.
But in that case, also, when you start doing that in publications with Shortman, with your supervisor, you will receive really I would say, review with rigor and scrutiny, and you may not be happy with what you're going to hear, but at the end of the day, if the idea is good and it can work and it serves the purpose, the intended purpose, there's always people in the beginning have resentment about something so innovative. You're giving me something for 1/10 of its price.
Yeah.
And I'm telling you, show me how good or not good. No, that is something that I think you should keep in mind, all the various aspects that would impact the practical application of your proposed innovative solutions of this.
Okay.
So
Thank you very much for the encouragement, Professor.
then always need encouragement for something like that.
We got a lot of feedback.
Yes,
Yeah, of
yes,
course.
but it's just the holistic things, and for all the students, always. Hello, Dr. Amin, how are you?
Sorry
All of
to
you.
come late.
Oh.
That was not my intention. I thought you are
Very
already
delighted to have all the professors here, but I shouldn't say, oh, and some also had, believe it or not, we still have corona. And some get sick, and some, of course, for all good reasons, they have to stay at home at least 5 days. I think the regulations now, Farzana was telling me that, correct?
5 days.
Yeah, for 5 days, yeah. But you cannot have 5 days after 5 days after 5 days and you're not doing nothing. You need to work. Okay, so thank you very much. I think
Thank you very much, everyone.
You still have a much for me, comments or a question.
Maybe we all need a closing remark from you.
Oh, I'm just delighted. I'm delighted to see the students after 2 years for me and not having such a beautiful session. We need to have by far more number of students, by the way, and the setup was a bit different. But then the idea was only a presenter like Alex today. And we gave Alex feedback and we gave comments also on how they presented work. And some of your slides were excellent slides. Others, the font was so small, no one can read them. And I think Dr. Sek can tell you all of that. But the idea here is how could we raise the level, number one, in the scrutiny of the scientific background and knowledge, the practical value, how you defend your work, and also just, I'm sure many of this, I myself learned a lot from your own presentation, and I hope that everybody benefited from that. And with that, but particularly this year, I really wanted to thank once again Hassan for helping us. Hybrid delivery, Dr. Bakshi and my colleagues, he was able to help us and enable us.
Yeah.
And I think even if you remember Dr. Nick Band and Dr. Siksik in the seminars, even in the board of advisory board for our center, the Center for Innovation in Construction, Infrastructure, Engineering and Management, that was great help. Thank you very much. Special thanks today. I want to
finish his PhD anytime soon.
Yeah,
That's cool.
I agree, but he has
But Hassan, you could probably start training somebody, when you are close to.
Yeah, we're getting people in online because we have to be.
You have done an excellent job.
Thank you so much.
No doubt, really excellent job.
In the lab, I think you have the procedure to transfer all the
Yes.
learnings to the next
From one
person.
to another.
And we have a backup all the time.
And special thanks today for our guest speakers, Dr. Mo, who was not, he had to leave because he had commitment with other meetings. Special thanks to you, Farzan. We're really delighted to see you. On a personal note, delighted to see you here with us. Yes, thank you very much. Yeah.
Nice to see you back.
Sorry, I didn't know.
And also, believe it or not, those who came late, this is mom of Alex.
Okay.
This is Alex's girlfriend.
Okay.
Alex's friend.
So this means Alex is fully committed.
Absolutely.
We should do that all the time.
Yeah, and also it's a special occasion because those who can make it today did not spare any energy. Dr. Hamad, I know how busy you are, and you had already a meeting. At the same time, he said, as soon as I finish, I will join in. He did join in. So thank you all for being here today. And with this, I'd like to wrap up this session. It's end of the academic year seminar in the construction automation lab. Thank you all very much.
And if I may say a last word, thank you, Dr. Musalli, for keeping the flame going. It's really outstanding that you are putting everything together, making it go relentless, and all our faculty members, Mr. Mikbag, Dr. Karimi, Dr. Hamad, everybody supports this center. It's really outstanding. And I think this is one of the centers which is very, very active, and we should all be proud of that.
Thank you very much.
Thank you.